So, from the formula given, we know that area of y is equals to 2 pi integrate a to b x square root of 1 plus dy dx squared dx. So, what we need to find is, find the area of y-axis. The equation given is y equals to 1 minus x squared with the limit of 0 to 1. First, we need to differentiate the equation of y. After we get the answer, we need to insert it into the formula that given. From the formula given, we insert the dy dx and solve the calculation until we get this. After that, we need to let u, which is use substitution, to get until we get the final answer. The final answer that we get is area equals to pi over 6, 5 times square root of 5 minus 1. So if you wonder how to calculate this, first we let u substitute, which is to make our calculation more easier. And then after we substitute u into this equation, we integrate the u and then we substitute back the original value of u and we calculate it until we get the final answer.
First, I open GeoGebra and select the 3D calculator. I make sure the algebra input panel is visible. Next, I enter the function f of x equals 1 minus x squared and press enter. This creates a parabola. Then, I restrict the domain of the function by entering g of x equals if 0 is less than or equal to x and x is less than or equal to 1, f of x. This keeps only part of the curve. After that, I create a slider by typing n equals 6.28. This value represents a full rotation of 2 pi radians. Next, I generate the surface of revolution by typing surface of G and y-axis. This rotates the curve around the y-axis. Finally, I press play on the slider to show the surface forming gradually, demonstrating the surface of revolution. This completes the construction of the surface using GeoGebra.
This diagram shows a three-dimensional graph created using GeoGebra. The red line represents the x-axis, the green line represents the y-axis, and the blue vertical line represents the z-axis. The purple shape at the center is a surface of revolution. This surface is generated from the function f of x equal 1 minus x squared. The function is downward opening parabola and only the portion where x is between the 0 and 1 is used. This restricted curve is then rotated to a full angle of 2 pi radians about n axis. As the curve rotates, each point traces a circular path, forming a three-dimensional surface. The final result is the dome-shaped solid shown in purple, which is symmetry about the axis of rotation. This demonstrated how a two-dimensional function can be used to generate a three-dimensional surface using GeoGebra.